Alright, so the goal of this lesson will be to, when given a system of two linear equations, the learner, which is you, will be able to graph the two lines and determine the solution by using the graphing method. There's two other methods we'll learn, which is the substitution method and the elimination method. But for this lesson, we're going to use the graphing method. So the directions, they're mistyped a little bit. It says graph the system of equations and determine graphically the solution. So what we need to know is what the solution is. The solution is where the two graphs intersect. Or two lines, I should say. Two lines intersect. Now, it doesn't always have to be two lines, but what we're dealing with in this lesson is graphing two lines. So it could be a parabola and a line, for instance, or any sort of where two graphs intersect. But again, in this case, we're doing two lines where they intersect. So let's start out by graphing the first line here. We have our system. Our first line is y equals the opposite of x plus 3, and our second line is y equals 2x minus 6. So again, we're going to start graphing y equals the opposite of x plus 3. The 3 is our y-intercept, that's our starting value. And this is a sneaky -1, and as a fraction that's -1/1. So from this point we go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. And if you want to go fancy, you could go up 1 and to the left 1 if you wanted to. So let's graph that line. Now with this method, you want to make sure you're trying to graph as accurately as possible so that your solution is accurate. Our next graph that we're going to put on this coordinate plane is going to be y equals 2x minus 6. So again, we're going to start down here at the y-intercept of -6, and our slope is 2 over sneaky 1. So again, we're going to rise 2 and run 1, rise 2 and run 1, rise 2 and run 1. Oh, look, there's our solution. So we found our solution, which is right here. That's our solution. So we have to write our solution as an ordered pair. So again, where do these two lines cross? They cross at a point 3, 0. So sideways 3, up 0. So the solution is 3, 0. Oh, sorry, I should write it down here where it says solution. 3, 0. Alright, let's try the next one. So our next two lines are y equals x plus 1 and y equals the opposite of x plus 3. So again, looking at my first graph, my first line, I'm going to start at 1, which is the y-intercept. My slope is 1 over sneaky 1, so that means I'm going to rise 1, run 1, rise 1, run 1, rise 1, run 1. Alright, so we're going to do that. Let's graph that line. Again, you want to be as accurate as possible. Whoop. And the next line is the opposite of x plus 3. So we're going to start at 3. And we're going to sneaky 1 over 1, sneaky -1 over 1, down 1 to the right 1. Oop, we found our point of intersection here. Down 1 to the right 1, down 1 to the right 1. So right here is our solution. Oh, you can see my graphs aren't very accurate. So our solution is, how do I get to this point right here? Well, I go 1 up 2. So my solution is 1, 2. Let's take a peek at our next graph. The next lines we're going to graph are y equals 2x minus 3 and y equals 2x plus 4. Now you may notice something peculiar about these graphs, and you'll notice what's going to happen in a minute. The first graph, 2x minus 3, we're starting at our y-intercept of -3, and we're going to rise 2, and it's a sneaky 1. Again, this is another one, 2 over sneaky 1. So we're going to rise 2 and run 1, rise 2 and run 1, rise 2, run 1. You can keep going as many times as you'd like. Again, try to be as accurate as possible. The downfall to this method of solving systems of equations is that if your graphs aren't accurate, you're not going to get an accurate solution. So, next graph, 2x plus 4. Starting at 4, and again our slope is 2 over 1. And I've run out of space to go up 2 into the right one, so I'm going to get fancy and go down 2 into the left one. Down 2 into the left one. Now, when I graph these two lines, you'll notice something. These two lines have the same exact slope. I'll put here same slope. And if you know anything about two lines that have the same slope, they're parallel. And if our goal is to find the solution, or where they intersect, we know that parallel lines do not intersect. So what we know is if you have two lines that have the same slope, that means they're parallel, which means they don't intersect, which means we have no solution. These lines will never intersect. And the last one. The two lines we're graphing are y equals 2x and y equals the opposite of x plus 3. So again, this is 2x plus sneaky 0. And again, our slope is 2 over sneaky 1. So I'm going to start my graph at the y-intercept of 0, 0, which is right smack in the middle at the origin. And my slope says I rise 2 and run 1, rise 2 and run 1, rise 2 and run 1. And you could be fancy and go to the left, down 2 into the left one if you'd like. And you're going to want to be as accurate as possible when graphing these. The next line we're going to graph is the opposite of x plus 3. Again, that's starting at 3. My y-intercept is 3. And my slope is a negative 1 over sneaky 1. That means I'm going to down 1 to the right one. Oh, there it is right there. Down 1 to the right one. Down 1 to the right one. I have enough points to make a line. And again, our solution is where the two lines intersect, which is at this point right here, which is at 1, 2. So the point is 1, 2.